Okay, in this question 58, which one of the following changes will be necessary lead to a non-spontaneous change? So we know that delta G is given by delta H minus T del S, where del S is your entropy, delta G is free energy, and delta H is enthalpy. Now, for a spontaneous process, del G has to be less than 0. So this is for spontaneous process, and for delta G greater than 0, that is positive, it is non-spontaneous. Now, for each option, we will make a tabular form. So we have delta H, delta S, and delta G. And let us conclude. If delta H is positive, okay, and delta S is positive, so this is positive and that is positive. Now, delta G can be negative at higher temperatures. So, at high temperature, del G can be negative. So this can be a spontaneous process at a certain condition. Okay, that is high temperature. Now for the next one, it is negative. This is negative. So over here, this is negative and that is negative. So this quantity will be as a whole positive. Now this can be delta G can over here be negative when it is low temperature. So at low temperature, we will say del G will be less than 0, that is spontaneous. For the next one, when it is positive and this is negative, now at this condition, okay, at this type of situation, del G is always going to be more than 0. So this should be our actual answer. Okay. So at this condition, when H is positive and entropy is negative, it will be non-spontaneous at all temperatures. For the next one, which says delta H is negative and delta S is positive, here del G is always negative, okay, or less than 0. That means always spontaneous. Let us go to the next problem, 59. Equal volumes of what concentration of AgNO3 and HCl should be mixed to form a AgCl precipitate? Now over here, theory is for precipitation to occur, Ksp, if it is given to be over here 10 to the power minus 10, the Kip, okay, should be greater than Ksp for precipitation to occur. That means it should be in the order of 10 to the power minus 9, something like that. So the first option, if you see, if you are mixing in A, we know Ksp is nothing but Ag plus concentration, Cl minus concentration. So for A, Kip, if you see, it is basically 10 to the power minus 11 by 2. Okay, so we will say no precipitation will occur over here. For B, if we check, it will be Kip again 10 to the power minus 11 by 2. For C, it will be KIP 10 to the power minus 12 by 2. Again, no precipitation will occur. For this one, it will be KIP 10 to the power minus 9 by 2. Yes, so this is over here. In this case, the KIP is greater than that of the KSP, and hence under this condition we will say the precipitation will occur. Solubility product of the Ag2CrO4 is given, which is 32 into 10 to the minus 12. What is the concentration of CrO4 2 minus ion in that solution? So here Ag2CrO4, if we think of it is sparingly soluble, then it becomes 2Ag plus CrO4 2 minus, so this is like 2S and this is like S. Okay, so KSP is Ag plus square and CrO4 2 minus. Okay, so this will be basically 2S square and S, and that is total to be 4S cube, which is nothing but 32 into 10 to the power minus 12. Okay, so that is going to come out to be as 8 10 to the power minus 12, that is S cube. So therefore we can say S to be as cube root of 8 into 10 to the power minus 12, or that should be coming out to be as 2 into 10 to the power minus 4. Now the concentration of Ag in solution is basically 2S, so it should be 2S is actually the concentration of, I'm sorry, not that is for Ag, but for CrO4 it is what? It is just S. So our answer should be over here 2 into 10 to the power minus 4.